Hey, Algebra 2. All right, so I promised yesterday we were going to talk about special cases. Like, what are these special cases about radical rational exponent equations when we solve anyway? Like, what will it look like if we have a no solution, infinitely many solutions? Can we have more than one solution? So anyway, we will look at those options. Let's recall some formulas. Let's say we have the nth root of x. If we raise that to the nth power, then it'll come back to just an x. So whatever the index is, we'll raise it to that power, and vice versa. Let's say we have something to a power, we can take the nth root of that and get back to just x. Let's go with rational exponents. If we have something to a rational exponent, we can raise that to the reciprocal, because then you have a power to a power and you multiply powers, which cross cancels those or cross reduces. Anyway, and you're left back to what you where you're at. And we use these properties so that we can solve anything, whether it's a radical or rational exponent. So let's see these special cases. So let's say we have the following situation. Square root of x minus 5 equals square root of x plus 7. In order to get rid of a radical, we're going to raise that to the index power on both sides. When this happens, the radical goes away. They undo each other, and we're left with x minus 5 equals x plus 7. If you try to get your x's together, so subtract x on both sides, the x's go away, and you're only left with negative 5 equaling 7. This is a false statement, so we say no solution. Let's say we started over and we had the square root of x minus 5 equaling negative 2. Again, we're going to square both sides, getting us x minus 5 equals 4. Let me stress that if you take negative 2 times itself, so negative 2 times negative 2, you get that positive 4. Add 5 to both sides, and we get a solution of 9. Here's the bad thing that we didn't talk about yesterday. We never checked our answers. Sometimes you think you have an answer, but if you don't check it, it may not check out. So, because if you take the square root of 9 minus 5, it actually does not equal negative 2. Because the square root of 9 minus 5 is the square root of 4, which is not negative 2. So this is another example of a no solution. And let me stress, 9 is an answer, an algebraic answer, but it's actually not a solution. Solution means it makes the statement true. Sometimes when we do the right algebra, it's within the check that it becomes no solution. We call this an extraneous solution. Extraneous meaning extra. It's an extra solution, like you got something but it didn't check out. So let's say we start over and we have the square root of x minus 5 equals the square root of x minus 5. Again, we're going to square both sides, and we're left with x minus 5 equaling x minus 5. If you tried to subtract the x's on both sides, they go away and you're left with, well, now you're left with a true statement. Because of that, that means a lot of numbers could go in here. Like if we could do 9, we could do 16, we could do 25, we could do 30. No matter what we put in here, the left side is always going to be the same as the right side. Infinitely many solutions. So where these weird situations pop up is sometimes when you're solving a system. So this is an Algebra 1 skill where you solve a system. Let's say you have y equals 5, which is a straight line across at 5, and then y equals square root of x plus 2. We could use the substitution property, like in this, if y equals 5, then that means instead of y in the next equation, I could just put a 5. And then solve the system to figure out, well, what's the x-coordinate to this solution? And so sometimes it could be within a system of equations where you have to use a substitution property. And depending on what the question is asking, again, I'm talking about standardized tests here, maybe they just want the x-coordinate, or maybe they just want the y-coordinate, or maybe they want the entire ordered pair, depending on the situation. We too could have weird systems of equations that we're going to try to solve.